Hi everyone, welcome again to another video of SAT Math Explained. This is our second to last video, and then we will have finished the whole series. So today our topic is about right triangles and trigonometry within the geometry domain. So after this we have one more video. If you have any specific topic you want me to make a video about, just let me know and I'll make a more focused video about it. And so let's get started. So what do you need to know to solve right triangles and trigonometry questions? So the most important thing is SOHCAHTOA. That's just a way to memorize. That is just a way to memorize sine, cosine, and tan. So what does this mean? O stands for opposite. A stands for adjacent, and H stands for hypotenuse. So you memorize it with so is opposite. So sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tan is opposite divided by adjacent. And yeah, that's all you need to know. Then you also need to know similar triangles. Just understand what they are. So what they are is basically two triangles. Or also any other shapes, but for this one specifically because it's right triangles, just know similar triangles is just two triangles. All the angles are equal, but they're different sizes. There's just like a triangle that has a pair, like an identical one that is shrunk up or shrunk down. Just be able to understand them and also be able to recognize them. So things like if you have two angle, you know, there's a lot of them. There's a lot of ways to recognize. The one that pops up the most on the SAT is just going to be angle. You have two angles two equal angles that tells you that they are similar. If you want a full video about it, just let me know in the comments. You also need to know the Pythagorean theorem. So you guys, I think everyone here should know that. If you don't, it's basically a squared plus b squared equals c squared, and this only applies to right triangles. So with the right angle, and then a and b, it doesn't matter which side it is, but c has to be the hypotenuse, which is basically like the diagonal. And basically you use this to, if you have two sides, you always use the Pythagorean theorem to find the last side. And then the last one is utilize the reference sheet. So I don't think I put it here. Yeah, I didn't put it here. But there's the 30, 60, 90 triangle, which is useful on the SAT. Okay, so I just added the reference sheet just so that it's clear. So basically, right here, they give you two special right triangles, and it basically just gives you the proportion or the ratio for the sides. So for the 30, 60, 90 triangle, you have 2x, x, and x squared root 3. And then for the 45, 45 triangle, it's just, let's say, s and s times root 2. So this might be confusing, like for me personally, it's confusing, because sometimes it's oriented, like, let's say, like, they flip it 90 degrees, and then it just confuses me. So the way how I like to use it is like I say, okay, so between the 90 degree angle and 30 degree angle, it's x root 3. Between 30 and 60, it's 2x, you know? So I refer to the angles so that when it's like oriented in a different way, it doesn't confuse me. And yeah, so that's pretty much all you need to know. And so how to solve. So what is the question asking for is the first important thing. Does it want you to solve for sides? Does it want you to find the area? Whatever. Just understand. And then you have to analyze the information. I know it's not specific, but it's hard to get specific with these types of questions. So what information is given? So look at, it's almost every time you're going to have some sort of shape, and it's going to have some information. And there's also going to be some information maybe in the text. And then just how can you use what you know, so these things, and the information given to solve for what you need. So let's just move on to examples. So as usual, please make sure that you're trying the examples on your own first, because just watching me solve it just gives you a false sense of understanding, which will not help you on test day. And we usually do 2 easy questions, 2 hard questions, and a single hard question. For this specific focus skill, College Board decided that none of them are easy. So there's only medium and hard. So we're going to do 2 medium, 2 hard questions today. So let's get started with the medium questions. So this one says, oh, I made them big today. So this one, we're given like a diagram, and no, it's not drawn to scale. For the given triangle, for the triangle shown, which expression represents the value of a? So I see that they give me a right triangle, which I can see. Never assume it's right triangle unless you see something like this, or it tells you in the text. So I see that it gives you two side lengths. It asks me to find the last one. So how can I solve that? I'm just going to use the Pythagorean theorem. Let's do that up here. So I know that a squared. Right here, it's like they made it already a. It's not always going to be a squared and b equals c squared. And remember, this does not look like a c. Equals c squared. So remember, the long side is c, and then 6 and the a and b, it doesn't matter which one. But this one's a, so I'm just going to say that this one's a. So I'm going to get a squared plus 6 squared equals 21 squared. And then a squared. So then I just solve for a. I'm going to subtract 6 squared from both sides, minus 6 squared. And then I'm going to put the square root, so I get square root of 21 squared minus 6 squared. So then from here, I'm not going to do that in my brain. I'm just going to put it into decimals. And note, because there's a subtraction, there's this subtraction sign, you can't just say, okay, square root of 21 squared minus 6 squared is just going to be 21 minus 6, because you have to subtract first. You have to do what's under the root before. Because if it's multiplied, that's fine. But if it's an addition or subtraction, you have to actually do it under the bracket. So, see right here, if you did just 21 minus 6, you'd get 15. If you do the square root of 21 squared minus 6 squared, you actually get 20.12. So a is equal to 20.12. 20.12. Let's see if that is an answer. Okay. So I didn't look at the answer options before I started, but if you look at the answer options, you would see it doesn't want you to simplify, it just wants you to give the answer in this form, which is option A. So this one, it only needs you to know the Pythagorean theorem. It doesn't want you to actually solve for it. Moving on to the next question. It says, in triangle ABC above, what is the length of AD? So, what is line AD? Line AD is right here. And so we just have to solve for it. So first thing, looking at this, I know that these two are equal. And that the whole thing, first thing I know that this is 30, and then this one's 60. So I know that these are two 30, 60, 90 triangles. And then, I know that they're equal, like this left side and the right side are equal, because it's an equilateral triangle divided in half, because this says 30, so that means this one's also 30, and it means that it was an equilateral triangle and it's been divided in half. So then I can just use the special right triangle in the reference sheet right here to solve for it. So what is the number that's given? They gave us one of them. They gave us the side length of 12, and that's between 60 and 30. So we're given, so that means that 2x, this is supposed to be, let's say, 2x, because it's the hypotenuse, is equal to, 2x is equal to 12. So that means that x is equal to 6. And then we want to find the one between 60 and 90. So we go back to the thing, between 60 and 90, the special right triangle tells us that it's just x. It's not being multiplied by anything. So from there you can just conclude that it is equal to 6. That is one way to solve it. The other way to be was to recognize that this is 60, 60, and then this one is 30, and then this other one is 30. So if you look at the triangle as in like the whole triangle, you would notice it's an equilateral triangle, so that would mean this one is 12 and this one is 12. Then you know that these two are equal because it's just dividing it by half. So this would be 6 and this would be 6. And then you would know that AD is 6. That's two ways to solve it. By the end, you would get 6 in both of them. So that is it for the medium questions. If you have any questions, please just let me know in the comments. And let's move on to the hard questions. We're doing 2 of them today. So this one says, a graphic designer is creating a logo for a company. The logo is shown in the figure above. The logo is in the shape of a trapezoid and consists of 3 congruent equilateral triangles. So it's in the shape of a trapezoid, and all these are congruent. So these 3 triangles shown in the diagram are all congruent and equilateral. So if the perimeter of the logo is 20 centimeters, what is the combined area of the shaded regions in square centimeters of the logo? Okay. So the perimeter of the logo is 20 centimeters. So the perimeter is basically the perimeter of the trapezoid is 20. Okay? That is what we know. What is the combined area of the shaded region in square centimeters of the logo? So I know that this thing plus this thing plus this thing is all, if you add them, the sides, you get 20. I also know that the triangles are all the sides in this are equal. So this one is equal to x, this one's equal to x, this one's equal to x, and so on. So I can actually make like a equation using the perimeter. I can say that, okay, so if this top part is x, let me do that in red. So if this top part is x, this top part is also x, and this x and x, I know that the perimeter is equal to x plus x plus x plus x plus x, so that, which is equal to 5x. And then I say 5x is equal to 20. And then I know that, and then I can solve for x, so that I divide both sides by 5. And then I know that x is equal to 4. So each side length is equal to 4. Okay? Let me just clean this up a little. So if each side length is equal to 4, that's a start. But let me just recall what it was asking for. I'm just going to write it once. So what is the question asking for? It's asking the combined area of the shaded regions. So the way I'm going to do it, I'm just going to try to solve for the area of one triangle, then multiply it by 2. So what is the area of a triangle? Again, I think it is on the reference sheet, I think. Yeah. So the area of a triangle is 1/2 base times height, and the height is from the a point down to the bottom at a right angle. So if I go back to the question, I need to find this thing. I need to find the length of this line. So how can I do that? Well, basically, if this is an equilateral triangle, so the height will be in the middle. So that would mean that this part is 2, and this part is 2. So from there, I can just focus on this half, and it's a right angle. So this half is right angle, and I can solve for the height using that. So how can I do that? So this is the hypotenuse. So I get 4 squared is equal to, let's say that b is 2, so b squared, I'm sorry, b is 2, so 2 squared plus a squared. Then from there I can just solve for a. I get the square root of 4 squared minus 2 squared equals a, and then a is equal to square root of 12. So that's the height. The height is square root 12. So from 1/2 base times height, I know that the height is square root 12. So now what's the base? The base is just the bottom part. So the bottom part, we solved it in the beginning using the perimeter. So the base is equal to 4. So 1/2. The base is 4. The height is square root 12. Then do I have to simplify? Yes, I do. So let's just multiply these. 4 times 1/2 is 2. And then times square root 12. You don't have to simplify it because what we saw in the answer options. Is that enough? No, we can see that they they simplified the radical. So how can we simplify the radical? We can basically say that this is 2 times the square root of 4 times 3. We divide 12 into 4 times 3 because 4 is a perfect square. Then you can change this into 2 times the square root of 4 times the square root of 3. And from there you can simplify square root of 4 to 2. You get 4 square root of 3. And that is how you simplify radicals. Yeah, so when you simplify radicals, you just look for perfect squares and you take them out. So the answer would be B. That is how you would solve this question. But, sorry, that was a mistake. So what we solved for right now is the area of 1. This is the area of one triangle. So if we look, we want the area of the shaded region. There's 2 triangles in the shaded region. So that means we have to multiply it by 2. So times 2. We actually get 8 square root of 3 as our final answer. So always make sure you avoid that mistake of just solving for something but forgetting to like multiply or divide or something like that. So the answer would actually be C, 8 square root of 3. And College Board will always make sure there's an answer option if you're just like in a hurry and you just solve for something, you just automatically put it in even though they didn't want that specifically. They wanted something else. Let's move on to the final hard question. It says in the figure above, tan B is equal to 3 over 4. If BC equals 15 and DA equals 4, what is the length of DE? So BC is equal to BC, so this whole hypotenuse is equal to 15. DA is equal to 4. We want to find DE. So at first you might look at this and you might seem confused. Okay, they tell me tan B is 3 over 4. So is it referring to the small triangle or the big triangle? Then you realize that you have to realize that these two triangles, the bigger one and the smaller one, are actually similar. Why is that? First of all, there's plenty of ways to actually find this. You could just realize because it tells you tan B is 3 over 4, you could just assume, okay, it has to be similar because there's a smaller triangle and a bigger triangle and they have the same, tan B is the same for both of them. Or you could basically see these two are parallel. So AC and DE are parallel. So because they're parallel, that means corresponding angles are similar, corresponding angles are equal, and we can assume that this hypotenuse, line BC, is a transversal. And because it's transversal, that means this angle is equal to this angle. This angle is equal to that's the same angle, sorry. So yeah, so this angle would be equal to this angle, and there's also the right angle. My bad. Never mind. So you actually won't have to need to do any of that of what I just said. Basically, you just do it through angle similarity. Both of them share angle B, and both of them have a right angle. That is angle similarity. That means the triangles are similar. You don't have to actually realize that these two are equal. So, continuing where we were. So now we have to solve for angle DE, for length of DE. So we have to use what we know. So if tan B is equal to 3 over 4, tan B is equal to 3 over 4. What is tan? Tan is adjacent over hypotenuse. TOA. So tan is opposite over adjacent. Opposite over adjacent. So B, the opposite angle, is this one. So this one is going to be 3, relatively 3. There will be a scale factor, of course. So if this one is 3, let's say, and I'm just going to put like a star next to it just to make sure it's not actually 3. It's just going to be relative to the other side. It's going to be, relative to the other points, it's going to be a 3. And then 4 is the adjacent. So this side is 4 technically. But then I can look at the hypotenuse and I realize this is a 3, 4, 5 right triangle. So basically, it's just a triangle that you just like memorize the sides. So 3, 4, and 5. So this special triangle basically, just write it. Okay, so this special triangle, basically, it's just something you memorize. If you have side lengths of 3 and 4, you will have a hypotenuse of 5 and so on. So if you ever see two of these sides with the hypotenuse of 5, you just have to know it. So this is this is a similar triangle to the two here. But it's not exactly. Why is that? Because we see that here is 15. So the scale factor for the bigger one is times 3. So if it's times 3, that means the bottom one is actually 3 times 3, which is 9. So this one is actually 9. And I'm just going to put this in red so that's not confusing. Is 9. And that would make this big one, it's supposed to be 4. It's going to be 4 times 3. It's actually going to be 12. It's going to be 12. So now what we need to do, we have to basically make a what's it called? I'm sorry, I don't know if I made it clear, but this whole thing is equal to 12. We're told that this small one, DA, is 4. This whole thing is 12, not BD. This whole thing is equal to 12. So from there, we can just set up a ratio to find DE. So let's use the long side divided by the short side. So I'm going to get 12 over 9, so 12 divided by 9 is equal to, 12 divided by 9 is equal to, this top part is 12 minus 4 equals 8 divided by, so how did I know that it's 8? Because this bottom part is 4, and the whole thing is 12, 12 minus 4, that means this small part is 8. So, and then we want DE, 8 divided by line DE. And then, you just solve for DE now. So, let's just cross multiply, you get 72 equals 12 times line DE. Find DE. And I'm just going to divide both sides by 12. Divided by 12. I get DE is equal to 6. And does that make sense? Yes, it does. Based on what? Also, this is one way to solve it. The other way to just also realize that this is another, what's it called? A 3, 4, 5 triangle, like I said. So, because this long side is 8, that would mean it was supposed to be a 4. Because it's 8, that means you multiply by 2. That would mean if this one was 3, it has to be 6, actually. 6. So those are the two ways you could solve this. If there's another way, let me know in the comments. If there's a faster way you know, please let me know in the comments. And this might have been a bit confusing. This is one of the harder questions, the harder of the hard questions. So if anything wasn't clear, if I said something confusing, please just put a question in the comments, and I'll make sure to answer it and try to make it more clear if it's not clear. So that is it for this video. Again, after this, there's only one video left. I'm not sure what's the topic, but there's one video left. And then that will be the end of SAT Math Explained series, unless you guys want a specific topic to go more in depth, let's say like factoring or similar triangles, anything like that. If you have, let me know in the comments. But that is it for today. Thank you for watching, and bye.